Okay, for problem 65, our first step is to take 18x away from both sides. This results in the polynomial x squared minus 18x plus 45 equals 0. So now it's in standard form, and we can try to factor that. So I have x times x and a minus times a minus to get a plus on the end and yet have a negative in the middle. We're looking for two numbers whose product is 45 and add up to 18. Let's see, 45 is 15 times 3. So that does the trick. So we get two solutions. This factor gives you x equaling 15, and this factor gives you x equaling 3. These are two solutions to this quadratic equation. Both of those are valid solutions to that equation. Now for problem number 66, we first have to distribute the x through the parentheses over here on the left side of the equal sign, and this x also distributes on the right. So we get 2x squared minus 8x minus 8 equals 3x squared plus x. We have to get everything on one side of the equal sign, so I'm going to subtract 2x squared from both sides and add 8x to both sides and add 8 to both sides. The result is that on the left we get 0. On the right we have 3x squared minus 2x squared leaves 1x squared. X plus 8x adds up to 9x plus 8. And that factors. Here a plus, there a plus. Here a plus, there a plus, everywhere a plus plus. And we're looking for two numbers whose product is 8 and they add up to 9. So 8 and 1 are the numbers. And so this factor gives us the solution x equals negative 8. And this factor gives the solution x equals negative 1. And so there, we found the solutions, two solutions to this quadratic equation. By the way, on this product, we're supposed to find the product of these two solutions, which is negative 8 times negative 1 equals 8. As in number 65, the sum of those two solutions they asked for in the problem, 15 plus 3 adds up to 18. So 18 is the opposite of the b term also. Anyway, finally we come to problem 67 here. And 67, we have some work to do. Foiling out the product of binomials here on the left. So we have 3x times x and 3x times negative 1 and 7 times x and 7 times negative 1. So what we get here is 3x squared minus 13x minus 8 equals 3x times x is 3x squared. 3x times minus 1 is minus 3x. 7 times x, 7x. And 7 times negative 1 is negative 7. Notice that when we subtract 3x squared from both sides, the quadratic term vanishes completely and we have what's left is just a linear equation. And let's see what we've got. We've got negative 13x minus 8 is equal to negative 3x, well, negative 3x plus 7x. 7x minus 3x is 4x. And now let's get all the x's on the same side of the equal sign, and it'd be nice to do it where they're all positive as well. So I'll add 13 x's to both sides, so I have a lot of positive x's over there. And if all the x's are over here, we want to get rid of this negative 7, so I'll add 7 to both sides. Adding these equations, we get, well, adding these changes to the equation, we have negative 8 plus 7 is negative 1. And 4x plus 13x is 17x. So finally, dividing both sides by 17, we've solved for x, and we get -1/17 is equal to x. So we've solved this quadratic equation, and there's only one solution to it, and it turned out not to be a quadratic equation, it turned out to be a linear one, but that's the solution to it.